So our first test for convergence for infinite series is one that we covered back in one of our first units during junior year, which was infinite geometric series. And so we determined that if you can write a series in the form of a geometric series. So essentially we had a sub n is equal to a sub 1 times r to the n minus 1 was our general term for a geometric series. So we said that that series converges if the absolute value of r is less than 1, or the other way that we wrote that was if the value of r is between 1 and negative 1. And so our first example here is show that the series, the sum from k equals 1 to infinity of 2 to the k plus 3 to the k over 5 to the k converges. And so, like with many of the problems we've done over these 2 years, if you have a single term on bottom, you are allowed to split the fraction. And so we can rewrite this as the sum from k equals 1 to infinity of 2 to the k over 5 to the k plus 3 to the k over 5 to the k. And if you want, you can look at these as two completely separate series. So the first one being 2/5 to the k. So again, since they're both to the k power, we're just able to put them in the same parentheses, plus k equals 1 to infinity of 3/5 to the k. And so with these, we don't really need to know what it converges to. We just need to determine if the series converges. And the fact that they say show that it converges, we already know that this does. But now if we look at each of these is now in the form of a geometric series. So in this case, the value of r is 2/5. And since 2/5 is between 1 and negative 1, that tells us that this part of our series converges. And then over here, our r value is 3/5, which again is also between 1 and negative 1. Therefore, this also converges. And so we find that if we add those two together, since each of the parts converges, we know that this particular series converges.